Venus has more volcanoes than any other planet in the solar system, more than 1,600. And a day on Venus, measured by how long it takes to rotate once on its axis, takes longer than the time it takes to complete a full orbit of the Sun. Wow! And that's just Monday. An extreme greenhouse effect warms the planet's surface up to 870 degrees Fahrenheit, hot enough to melt lead. Winds there reach the speed of 450 miles per hour in the middle cloud layer, faster than the speediest tornadoes on our planet. The pressure on Venus's surface is 90 times higher than that at sea level on Earth. What a great place for a vacation, huh? And recently, this incredible place has become even more intriguing. In the toxic Venusian atmosphere, there's something that might mean the existence of life. Unfortunately, scientists haven't had a chance to collect any microbe specimens or snap any pictures of life there. But they've discovered a chemical called phosphine, and it's a big deal.
If it's not some previously unknown chemistry that produces the gas, then there must be a kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any normal life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially.
The weirdest thing is that phosphine isn't supposed to be in Venus's atmosphere at all. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, the famous gas giants, but on Venus? Totally unexpected. There's no way phosphine can be produced naturally on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere. But it's not nearly enough to explain what the astronomers have observed. It would only make 1/10,000th of the phosphine the telescope saw.
But let's start from the very beginning. In 2017, a group of scientists led by Jane Greaves from Cardiff University started to use the James Clerk Maxwell Radio Telescope in Hawaii. That's a mouthful. The main idea was to search for phosphine gas. It would be a sign of life on Venus. When the data came back and the researchers analyzed it, they were shocked. The phosphine signal was powerful. The team checked the results several times. They wanted to make sure no other substance mimicked the presence of phosphine gas.
So now, does it mean there's life on Venus? Well, not necessarily. If this gas is created by some mysterious organisms, it's a big question how they survive on Venus. On our planet, some microbes can thrive in the environments with the acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid. And even though they have a rather pleasant temperature of 86 degrees Fahrenheit, these clouds contain more than 90% of sulfuric acid. DNA, amino acids, proteins, life components on Earth would be dissolved there in the blink of an eye. The surface of the planet is too hot for any kind of complex molecules to make up life. The Venusian atmosphere is almost 50 times as dry as the driest place on our home planet. There's a theory that microbes might hide in scarce water droplets floating in the atmosphere, but it hasn't been proved yet.
Right now, the research team's waiting for more telescope time. They're going to look for other gases associated with life. But even if they find more evidence, life forms on Venus will be made up of building blocks absolutely different than those on Earth. Or they might be protected by a sulfuric acid-resistant shell. It can be made of such substances as sulfur, wax, graphite, or something else we can't imagine.
Of course, some experts question the idea of life on Venus. They think the gas might be produced during some geologic or atmospheric processes happening on the planet. But the supporters of both theories agree on one thing: the discovery is extraordinary. Interestingly, astronomers have always tried to find signs of life on giant planets' icy moons, or even closer, on Mars. But they've never seriously considered Venus. If additional telescope observations and future space missions confirm that phosphine is produced by living organisms, we can be in for a bunch of exciting surprises. Then people would know of a planet with an alien biosphere, well, alien to us, and this planet would be just next door to Earth. Now, speaking of visiting Venus, though, would it be possible for people to land on this planet? After all, robots are already tooling around the red planet surface. On the pro side, Venus is closer to Earth than Mars, but it also has much harsher conditions. The planet is hotter than Mercury, even though Venus is almost double the distance from the Sun. The temperatures are higher than the melting point of many metals, and some of them, like lead or bismuth, can fall as snow on the highest mountain peaks. If you set foot on the planet, you'll find nothing but barren rock. Giant basaltic plains are littered with volcanoes and mountains. In some places, the surface melts because of the heat underneath. After it releases some of it, the rock solidifies again.
If people ever go to this planet, they will most likely build floating cities in the clouds of Venus's atmosphere. At about 31 miles above the surface, the conditions, like the pressure and gravity, are similar to those on Earth. The temperature is rather manageable too, at around 167 degrees Fahrenheit. Think Death Valley, California on a really hot day. The atmospheric pressure is half of what we have at sea level on our planet. If you went outside, you'd be fine without a pressure suit. The pressure you'd feel would be the same as at the top of Mount Kilimanjaro. Plus, this colony would be protected from the sun's radiation better than one on Mars.
If the atmosphere was the mission's final destination, landing a spacecraft, or rather making it hover in the air, would look very different. The idea is to use an airship in the upper atmosphere for long periods of time. The airship, wrapped in an aeroshell, would enter the planet's atmosphere at a speed of 24,000 feet per second. In the next 7 minutes, its speed would drop to around 1,500 feet per second. After that, a huge parachute would open. It would slow the spacecraft down even more, and then things would get a bit hectic. The aeroshell, not needed anymore, would drop away. The airship would then inflate itself, all the while hurtling through the atmosphere toward the planet's surface. Its speed would be at least 330 feet per second. It would get larger and larger, and its drag and lift would increase. Soon, the parachute wouldn't be needed anymore. The crew would get rid of it, and the airship would fill with air completely. If everything went as planned, it would stop 30 miles above Venus's surface. After that, the airship would travel around the planet. It would be moved by the wind, which can reach a speed of 220 miles per hour at the top of the cloud layer. If you decided to move closer to the surface, though, you'd have to be extremely careful. The wind in the middle layer can get twice faster. The airship could be filled with a breathable mixture of hydrogen and oxygen gases. Such a combination would be less dense than the Venusian atmosphere. It would provide the needed buoyancy, to stay up there. Venus is famous for its super dense clouds. These clouds make the planet shine bright enough to be seen from Earth. Venus reflects more than 75% of the light that comes from the Sun. This reflective cloud layer exists thanks to a haze of sulfuric acid droplets in the atmosphere, and they gather exactly at the height where the airship would float. Luckily, people already have a method to overcome the problem of acidity. A few materials, for example Teflon and some types of plastic, have an amazing acidic resistance. They could protect the outsides of the ship. So, let's say you needed to work on a platform outside. Then you'd be able to do it, wearing only a chemical hazard suit and carrying necessary oxygen supply. Ooh, sounds like fun, huh? Yeah, me neither. Ah, Earth. The third rock from the Sun. The blue planet. You get it. Its atmosphere is made up of around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide. A nice balance for any living creatures to breathe. The weather here is also perfect for life to exist, unlike places like Saturn, Mercury, or any other celestial object in our solar system. We have the troposphere to thank for that. It's the densest part of the atmosphere on our planet and is 5 to 9 miles wide. It's the layer of the atmosphere that always affects our weather and secures the right conditions for life to exist and to have bodies of water. Earth is just sitting in its orbital path, minding its own business, revolving around the Sun until, BAM! Venus and Mars swoop in and spoil the fun. No one wants to leave poor Earth alone. These two relatively large celestial objects moving toward Earth will have dire consequences for our planet, starting with changes in its orbiting trajectory path. The planet's orbits in the solar system have to maintain the right balance so that nothing goes haywire. Of course, if any large object approaches Earth, it would throw our orbiting path off course. The planets will revolve around each other, which will cause plenty of natural disasters on our lands. This will also affect our rotation timing, potentially slowing it down. Days will not flow but drag by. Animals that rely on daytime will need to readjust their biological clocks. Nocturnal animals will also need to figure out how to cope with the long nights. Humans have adjusted pretty well to the 24 hours a day timing. Time itself is just a human construct to measure things. We'll have a tough time sleeping and adjusting to the stretched day. Marine animals rely on the natural current flow to migrate around the oceans. With Mars and Venus crashing the party, it looks like they will also need to find new paths. Birds migrating to other lands throughout the year will also be confused and not know what to do. In general, the Earth's temperature will rise, and massive heat waves and permanent climate changes will occur. This brings us to our next issue, the heat. The radical temperature rise will turn everything into a barren desert. It'll be summer all year long, especially if Venus is in the picture. Most of the planet will dry up and won't be suitable for growing crops. Venus is hot, really hot. Even though it's not the closest planet to the Sun, it's still the hottest. The temperatures on Venus are close to 900 degrees Fahrenheit, which will melt you like an ice cube. The lands on Venus are generally flat, probably due to the temperatures. It's mainly hot because its atmosphere is thick and traps the hazardous gases inside. If Venus inches its way towards us, it'll invite those gases to our atmosphere and compromise it. Mars, or the red planet as we know it, is very cold. That might stay the same if it starts rotating around us. It's also home to the largest dormant volcano in our solar system, which makes Mount Everest look like a tiny bush compared to a tree. With so much instability, it might just wake up one day and spew out molten lava. Mars has a very thin atmosphere, which makes the planet chilly. Its gravity is quite similar to ours. It's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and sunset. The three planets orbiting each other will eventually collide. It's just a matter of time. And the Moon, just hanging out like a fly on the wall, will be so insignificant that something will eventually throw it off course and another planet will capture it to its orbit. Or, in the most dire case, it will collide with one of the two intruding planets. Earth will experience extreme tidal waves like nothing before. The two new planets revolving around Earth will cause a major imbalance, making our gravity shift out of control. Each tidal wave will be bigger than the previous one and will cover the dry land. Plenty of little scattered islands in the oceans will be completely submerged. Coastal cities and towns will also be home to fish. Flat countries in general will need boats to get around. Dams and dikes won't be enough to stop the water from coming in. Everyone needs to move towards higher ground to escape the floods. With the climate getting hotter, the polar caps will melt like ice cream on a sweltering summer day and add to the water level rising. Within a few months, the whole Arctic will be nothing but liquid. But wait, there's more! The crust will wear out due to the instability of the Earth's surface and fluctuating gravity. The Earth's crust is mainly made up of oxygen, which means we're basically walking on air. We might experience more earthquakes than before, and dormant volcanoes will wake up from their deep slumber. The skies will be covered in ash, making flights impossible. No one can travel by sea or by air. Importing and exporting will become history. The overall climate will get hotter, just like in Venus. The three planets orbiting each other and their huge mass might even unintentionally welcome other planets and celestial bodies to join the party. So, what if Jupiter decided to turn up? Now, Jupiter is the largest planet in our solar system. To give you an idea, the Earth would be just the size of a grape if Jupiter were the size of a basketball. It also has the largest storm we can perceive. That's known as the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. Now, by the time you're done watching this video, you can expect the storm to still be going at it. Since the planet is huge, gravity must be quite strong here. It also has many moons, some of them of our little Earth. There will be no room for any proper space among the planets. Jupiter's moons will be thrown off course and latch onto other planets around. Some of the moons might collide with each other, causing massive debris to be displaced all over the place. The gravity of the planetary party will attract comets to enter the atmosphere, potentially crashing down on us. Oxygen levels will deplete, so the Earth's crust crumbling will continue. It'll rip open the ozone layer, causing heavy strokes of ultraviolet waves to enter our atmosphere. We won't be able to step outside for too long without some protective gear and oxygen tanks. Human civilization will change drastically. We'll all live in sheltered containers that will provide clean air and safe and filtered sun rays. The shelters will be sturdy enough to withstand frequent earthquakes. We will grow only enough crops to sustain ourselves until we leave the Earth. Since it'll only be a matter of time before the planets collide, the next step would be to create large rocket ships to fly us out of the Earth. With Mars, Venus, and Jupiter revolving close to us, it won't be easy to do so. All the space debris will be blocking us from exiting the space zone area. The only safe place outside this region will be many millions of miles away, where only single planets exist. They may or may not have the conditions to host life, but humans will have the technology to land just about anywhere with similar gravity and construct the right shelters. Eventually, Mars, Venus, Earth, and Jupiter will collide with each other and break like eggs, like a big space omelet. Don't forget the moon's crashing and breaking in the mix, but we'll already be far, far away by then, hopefully. What would happen if our planet turned into two separate ones, one consisting entirely of land and the other one of water? Could we survive on any of them, and how? Well, you're lucky, because I'm going to answer this question right now. So let's imagine that our Earth has turned into two separate planets sharing one orbit. Let's call these hypothetical planets rock and water. I know, very original. Anyway, let's start with the rock because this one is much easier to imagine. All we should do is ask, what would happen if all the oceans on the Earth suddenly dried up? Now, we know that water is life. It covers 70% of the surface of our planet. There's so much water that even if all the oceans and seas disappeared, some of it would still be left in underground rivers, streams, and so on. But unfortunately, it would not be enough for us to survive. All sea creatures disappear. After some time, all other animals, plants, and of course, people share their fate. Completely dried forests burst into flames sooner or later and burn until there is nothing left but ashes. But hey, it's not that bad. Well, it is bad, but life can still exist in some form. There are some bacteria that make cockroaches jealous. They're able to survive absolutely any conditions. For example, extremophiles have already evolved to live without water. These little guys can survive in an incredibly hot or acidic environment without water or even sunlight. Without them, the rock becomes an empty, lifeless planet. Although, who knows? Maybe someday extremophiles will be able to evolve into some wildly cool forms that can survive literally anywhere. But for now, the rock is just a floating rock, basically. Oh wait, did you imagine a hot desert or some sort of red-hot steppes? Surprise, surprise! This planet is actually extremely cold. You see, without water, there would be no atmosphere. The atmosphere consists of a concentration of various gases, including hydrogen and oxygen. Some H and O, you know where this is going, right? Yep, no water, no atmosphere. And since it is the atmosphere that accumulates all the heat we need, the planet would be very cold without it. The contrast between cold and less cold places also becomes very sharp. You see, water is basically a climate stabilizer. The oceans absorb almost all of the heat of our sun. They distribute it evenly over the Earth to make sure it doesn't get too cold or too hot. So without it, the rock gradually turns into a cold desert. The average temperature on this planet is around minus 100 degrees Fahrenheit. At both poles, the temperature is extremely low, about minus 300 degrees. And even in the warmest places, it doesn't exceed 20 degrees. These warm places are now the former oceans because their dried up depths are located much closer to the hot core of the planet. Wait, I hope you don't imagine this planet as covered in snow either. We don't have any water at all, remember? It's just a very cold rock. At this point, we're just a bigger and browner version of the moon. The moon is basically a waterless piece of Earth after all. But hey, what happens to volcanoes? They're basically our last hope to stay warm, aren't they? Unfortunately, volcanic activity is decreasing due to a lack of water. You see, volcanoes and their eruptions happen because of the collisions of two tectonic plates, the oceanic and continental ones. The weight of the water presses on the oceanic plates. They go under the continental plates and form volcanoes. So if there's no water weight, then there's no volcanoes and volcanic activity drops significantly. The rock now is just a planet full of many incredible high mountains. And every time the tectonic plates collide, they form more and more of these mountains and trenches, including some very big ones, like the famous Mariana Trench. I would say, be careful not to fall, but hey, there's no one to fall there. So? Also, there's no weather anymore. No water means no more snow, ice, or rain, or even clouds. The wind would probably be quite strong, though. Well, that's the fate of the planet rock. Not very bright, so let's just go see how the water planet is doing. Many billions of years ago, I wasn't around then, our Earth actually was a planet entirely covered with water. Then, about 1 billion years ago, the sea level dropped, the land appeared. This has changed the atmosphere of our planet forever, and that's how life was born here. But what happens if it returns to its original state? Well, to answer that question, we should first learn more about the ocean planets. So, what does one of these look like? Oh, sorry, I almost forgot. We have no idea. We haven't found any planets of this type because they're incredibly rare. I mean, there is one planet that is low-key and could be called an ocean planet. Yeah, I'm not even going to try and pronounce that. Still, even this one doesn't look the way you probably imagine. The water on it is in a very weird, unique state. Scientists have called this hot ice or superliquid water, and we've never seen anything like this before. In general, though, the actual ocean planets are very hard to find due to many physical reasons. These planets require very specific temperatures, pressures, and so on. But alright, just hypothetically, what would such a planet look like? Well, first of all, of course, it cannot be made entirely of water. I hope you didn't actually think that there could be just some gigantic water blob spinning around a star. It should still be a planet with a core and some kind of foundation. So let's just imagine that all the water on the former Earth has mixed into one giant salty ocean. Wow, that would be a dream come true for the sea creatures, but not for the rest of us. The only animals that could survive in this situation, except fish, are probably the birds that can swim and feed on fish. Now, I think even if the sea level rose significantly, at least a couple of islets could still stay above the water. Such islands would be the former peaks of huge mountains like Mount Everest. So if these birds build their nests there, they can even survive for some time. But what about you and me? Well, we still have a chance. If we had enough time to prepare for the huge flood, we could stay safe either in giant submarines or on giant ships. We can grow food on board and fish from the ocean. But without the Everest Islands, we are unlikely to last long. If something breaks and we have nowhere to dock, we won't be able to fix it. Unfortunately, we no longer have drinking water. Now we can get it only from rain or by filtering seawater. But we have to store it someplace, right? And all these water containers would take up a lot of space and be very heavy. But in general, planet water is not as bad as it might seem. It's quite warm. The average temperature here is about 50 degrees Fahrenheit. And the gap between the lowest and highest temperatures is minimal, from minus 20 degrees at the poles to 70 degrees at the equator. Compared to planet rock, this ain't bad at all. Planet water would also be slightly larger than the Earth in radius due to the volume of, yes, water. The density of this planet would be, on the contrary, quite low. The gravity could become a bit weaker, too. Now, as for both planets, if we place them in the Earth's orbit, after some time, they would still move away from each other and follow different trajectories. They would have aligned themselves not to collide with each other. On one of them, the year would last 12 months, and on the other one, 10 or 11. And that's about it. A fun fact: all of this can actually happen in the future. First of all, the Earth's crust is gradually becoming thinner. Hey, I like thin crust. On my pizza. On my planet, not so much. So, one day, water can really flood our entire land. On the other hand, in a couple of billion years, when our sun begins to expand and turn into a red giant, all the oceans on our planet will really dry up. Alright, take a deep breath and shake it out. That's enough of this grim fairy tale. It's a waste of time to worry about such things so far off when, today, I can't find my wallet anywhere. I thought I put it over here. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.